Measurement uncertainty tells students how much the numbers from an experiment might wiggle, and that we can show it by taking repeated readings, showing the spread, and using significant figures to reflect that wiggle. When you teach this, have students measure the same thing many times so they see the numbers are not exactly the same each time, and explain that the small differences come from limits of the tools in human reaction. Show them a simple list of repeated readings and draw a quick dot plot or number line so they can see the spread. Then, calculate an average as the best single value and a range or standard deviation as a measure of how much the readings vary. Explain significant figures by pointing out which digits are reliable and which are estimates, and show that writing uncertain digits tells people how precise the measurement really is. Use simple language and hands-on practice so the idea that measurements are not perfect becomes obvious. Students often think one reading is the true value, so remind them that one measurement is just one sample and repeated readings give a better picture. Encourage taking several measurements and reporting an average with an uncertainty. Another mistake is ignoring the tool limits, so teach them to note the smallest scale division and use that to decide how many significant figures to report. Some students confuse precision with accuracy, so explain with examples that precise repeated values can still be wrong if the instrument is biased, and show how calibration or comparison to a known value helps check accuracy. Visit www.gumballdegree.com to find more videos and resources that show repeated readings, spread displays, and how to use significant figures to report measurement uncertainty.